Today we're talking about spheres and finding their volume. A sphere is a set of points in space that are all about the same given distance, known as the radius, from any given point known as the center. Okay, so what that means is this part of the sphere is called the center. This part is the radius, just like it would be in a circle. And this cross section is what we call a circle. When we cut it across this cross section, we can call it a hemisphere. So we're talking about anything that is this shape of a sphere, a basketball, the moon, planets, shapes like that. So the volume is 4/3 the pi times the radius, but we're going to cube the radius. So find the volume of the sphere and round to the nearest tenth. We're going to first plug in our formula, 4/3 pi r cubed. And we're looking for radius. Do we have it? Yes. We have 6, so we have 6 cubed times pi times our 4/3. Okay, so when we do this one, we would get a total of 904 and tenths, and this is the volume in cubic millimeters. So you can write millimeters cubed, or you can spell it out like this. Okay, so a spherical stone in a courtyard of the National Museum of Costa Rica has a diameter of about 8 feet. Find the volume of the spherical stone and round to the nearest tenth. The first step is to ask yourself, what information do they give you? They tell you it's a sphere, so you need to write out the formula. 4/3 pi r cubed. Then you need to look at what information they give you. They give you the diameter is about 8 feet. So if the diameter is 8, what is the radius? All right, I want you to try the rest of this problem for me, and I'll be back in just a second to show you the answer. Okay, so in your notes, I should see your work, and now you're going to check it with my work. So make sure that you have a red pen or some other color, just a pen in general, that you can check your work. Okay, so here is what I did. First of all, I figured out the radius would be 4, and I plugged it in. I cubed the radius, which would be 4 times 4 times 4, and then I multiplied that times pi and times my 4/3. So this was 64, and I multiplied them all to get 268 and 1/10, because they asked me to round to the nearest tenth, and these would be cubic feet, or feet cubed. Okay, so what about one of those things that we were talking about before, the hemisphere? When it's cut by a cross section, we have 2 hemispheres. So what are we really doing? We are cutting the sphere in half. So find the volume of the sphere and then cut it in half. All right, I'm going to leave you to it, so go ahead and try this one, and I'll be back in just a second to show you the answer. Okay, so just like the previous question, you are going to make sure that you check your work with a different colored pen. All right, so volume equals 1/2 the 4/3 pi r cubed. So here is my volume of my sphere, and this creates the hemisphere. So when I multiply, I take 5 times itself 3 times, and I get 125 because it's 5 cubed. And then I multiply that times pi, which is 3.14, and times my 4/3, and then I cut it in half, or I multiply by 1/2, and I get 261 and 8/10 cubic centimeters, or again, centimeters cubed. A hemisphere has a diameter of 9 centimeters. Which of the following is the closest to the volume of the hemisphere in cubic centimeters? Go ahead and try this one, and I'll be back in just a second to show you the answer. Okay, so here we go. The formula is 1/2 of our actual sphere's formula, 4/3 pi r cubed. So if they give me the diameter is 9, the radius is 4.5. So we first have to cube it. So when I plug in my numbers, I get 190 and 755 thousandths. But they want me to write it in, of course, the choices that they give me are hundredths. So I'm going to look at this 5, and this 5 tells me to round up, and I get 190, so, and this would be 76. So they ask us for which is the closest to the volume, so A would be the closest. And that's all I've got for you today. I'll see you next time.